Okay, let's do some stress strain analysis in Autodesk Inventor. So first start off by making this plate with a hole, and we'll apply a force out on here on the end with this part fixed to see where the points of high stress are. So let's begin by making a new part. And we're also in a new chapter, so let's close down our previous project from chapter 16. And yeah, we have to go over here and make a new area. So let's go to Manage Projects, New, Chapter 17. Oh, looks like it already existed. So you just select it from the list right there. Okay, so let's start our new part. It's going to be a standard English unit part. Create. And let's just stand this one up against the wall and make it simple with a 2-point center rectangle. I believe this distance right here is 6 inches. And I think the other one is 4. Doesn't look exactly right. So let's look through some of the instructions also while we're here and see how we're supposed to apply this. We see that we're going to use finite element analysis where we break it up into multiple pieces. Okay, it looks like it's 2 inches there, 2 inches. Okay, so it's 3. Yeah, it does look like. Okay. I don't think that was the part that we were looking at though. Okay, here we go. So it looks like it is going to be 2 inches by 6 inches, and we're going to have a 3/4 inch hole in the middle. And so let's change this one. Doesn't look to scale necessarily. And of course, what we want is a thickness. uh, Maybe use bidirectional extruding for that one, in case we need symmetry for this one. And it looks like we're going to use a thickness of, I think it says 1/4 inch right there. Yeah. All right. And then we're going to change the material also to aluminum 6061. Select all, or right click on the part. Oh yeah, let's save this as 17.0 because it's within the chapter. And right click and select eye properties, physical, material, aluminum, and apply. Kind of has an aluminum look to it now. So now we're going to do our stress and strain analysis. And I always forget how to get to that. So we just go and look for, oh yeah, it looks like it's going to be in environments. This is where we're also doing our 3D printer as well, which we can just, our 3D printing rather. That's how we made the STL files is on the environments tab, but also we're seeing stress strain analysis. So environments, stress, and then I think what we can do is begin our study. And so you can do multiple studies and, put fixed, uh, you can make the top fixed or the bottom fixed. We're just going to make the left-hand side fixed. In other words, we're going to glue it to the wall. So here's the symbol for a fixed right there. We select that location, hit apply. And then if you go back to this home position right here, I think you should still be able to see it. Yeah, so it's saying that that end is fixed right here. I believe that we're doing a force, not a pressure on this end. And I think we're going to pull it. So I change the direction, and I believe it's 300 pounds. All right, let's double check those settings as we go through this exercise. We've created our study. We had a static analysis. I forget why we had to use, oh, the guide kind of just describes what I'm doing for you already. Um, And I think we've already assigned the material just by selecting it, but let's double check that we have done that properly. So assign, and it does look like we already have that. So when we set up the eye properties, it appeared to do exactly what we wanted. Okay, it says assign materials. So I guess we'll just double check that for this right here, assign materials. Yeah, I'm not really sure why they're having us do that again. And we set one end fixed, and then yeah, we select a face, we apply the force, and we put 300 pounds on there. We have the fixed constraint in our feature tree, and now we're going to break it up into finite elements. So that's why it's called finite element analysis, is because we're going to turn this into a grid. So there's the mesh view, and that's not very many elements, so it's not going to be that accurate when we run our simulation. Okay, and so is it this one right here, I think? And so we're going to be doing just stress and strain down here. We want this one selected, von Mises stress. And you see right here, I get a maximum of 2.084 uh, kilo. Let's see. So instead of PSI, pounds per square inch, I think that means kilopounds per square inch. And you're probably going to get a different number there because it kind of depends on what mesh it uses. Um, every computer is going to select a different kind of random collection of mesh elements, I think. But if we begin to increase the number of elements to be like 0.05 and have that be the average element size, and I think we can go back over here to mesh view again. No, that didn't seem to work. How do we get it to reload that? Uh, or do we have to just run it again? All right, let's run it again, and it should take longer. Oh, didn't take very long, but you do see that perhaps my triangles are a bit smaller. I think there was a way, mesh control. Okay, and you can see this one's going to be, I think, closer to the value that you have. I'm going to go one step further and just go to 5 like that to show you that if you run the simulation now, probably take a little bit longer. Well, not that much longer. And we got a little bit of convergence happening on the maximum stress where this red point is right there. All right, if you want to look at displacement, you go over here and you say activate that one. So now this is displacement, and you can run the simulation just to make sure. And you see that most of the stretch happens out here, obviously, since this is glued to the wall over there. So the opening, as you might be able to tell, is now oval. This is exaggerated, I'm sure, because look at the small amounts that it's moving. And that's what the software packages normally do, is they exaggerate the stress, or the stretch rather, um, when they run these simulations. Okay, and so to kind of prove that you have done the stress strain analysis, you could do a print screen. And what you really want to do, though, is make sure you include your parameters, especially the maximum displacement and maximum stress. And so save screenshots of those analyses, uh, the stress up here, and the displacement. And so upload those two images into D2L. And so while we're here, oh, there's another thing we can do is we can increase the number of elements, I believe. Also, we might be able to tell how to refresh the elements once we change it. Yeah, there it is. Update mesh. That's what I was looking for a moment ago. So you have to right click in the feature tree in order to get that to work. Now, I want to give it a little bit more um, resolution in this area here. So that's where we're going to add some more elements where it's needed the most. So we will add more elements to this surface there and maybe just do 0.01 in that area. Or we could go by their example, which it says, oh, zero point 0.1. So maybe not as much as I did. And then if we right click on this and then say refresh or update mesh, you'll see that it put a few more elements in this area so that when we run the simulation, it's going to give us more granular data in this area. Okay, and I think we're still converging. So we've been around 2.18, 2.19, 2.2. And so that's good enough for what we're looking for. If we want to keep going, we would have to increase the number of mesh elements. But let's do another one. So let's go here to the back of the chapter and let's find some more shapes to test. Um, how about this one? Okay, this looks pretty straightforward. Let me make sure it's part of our assignment in chapter 17. Yeah, so we're going to do stress and displacement on this one. So it looks to be 60, 60, 30, and 15. Let me see if we can remember all of those things. I'm debating on whether we should do a revolve or not. Might be overkill on the revolve, but never hurts to get some more practice. So staying in English units, nope, sorry, let's go to metric units. Um, that standard one right there. And let's go ahead and let's see which plane we should put this on. Maybe on the bottom. And we'll begin by saying that we're going to start here, go up here, then down, and over here, and here, and then come all the way back for our axes. So we'll turn that last one right there into an axis, and we'll see how close we got here. Not very close. I think this one needed to be 60. But it's going to rescale it for us, and then we just zoom back, put the other one at 60. And I believe this one right here needed to be at 30. And this one right here needed to be at 15. And then we'll see if I remembered everything. One thing we could do is put a fillet right in there. Let's see if we want to do that. We can do it the fillet before or after the revolve, it turns out. It's a 5 mm fillet. Looks like we got everything else correct. So we have our choice of doing the fillet in the 3D model, or we can do a fillet during the sketch. I am going to try to do it here. Not there. It needs to be between this area and that one. That's where it needed to be. I think that's right. Double check. Yeah, that looks a bit big though. Oh no, I think it's okay. Okay, just wasn't looking at that right. Look at how fast it makes the part. Just in one click. It's the power of the revolve and the center line. It's time for some stress analysis. I really kind of wanted it the other direction. So what we can do is, I guess, go over here and then right click on the view cube and say set current view is this one. And then we go to this right view and let's set that one as the front. So that way it looks like what we have in our diagram here. Now, if we're looking at the type of material, I don't know if we have that one. And looks like we'll make it fixed on one end, on the large end, and then we're going to pull it with 50 kilonewtons in the metric system here today. right click on the part, eye properties, physical, and then we look for ANSI. I don't think we were able to find it in our list during class. So we will just select any number, any one on here that says ANSI on it, or AISI, excuse me, AISI. So we will select that one for our analysis. And it's time to begin the analysis. Remember, go to environments, select stress analysis, and then we begin our study. It's going to be not a dynamic analysis, but a static one. Put our fixed end over here against the wall, glue that up against the wall, and then we're going to put a lot of force out here on the end. And I know that it's a force because it says kilonewtons. So let's see if it'll take that. Might have to put the extra zeros in there. Nope, it took it perfectly. And is that it? Is that all we do for that one? Let's do our analysis. Looks like we might need a good number of extra elements in this area. So file, save as, and we are in chapter 17. This is problem 17.1. We're going to need to take some screen captures of this. So doing some of our stress analysis on this one, we will go over to our environment where we're doing the stress analysis. And stress analysis. Okay, so going to the analysis over here, we've already created our study. So then I think we can just do our mesh view and say that that's clearly not enough. Um, I'm just going to guess at some values here. So in this area, I'm going to put 0.1, just like we did in this other one. And I'm going to put it around this one because it looks kind of uh, bigger elements than out here. And I might even put them in this area here too. Now let's see if we update the mesh view, if that really did what we were hoping it would do. And did I make it overkill? Because it seems to be taking a bit longer. I may have overdone it a bit. I'll pause the video. So that one was taking a long time. So I decided to stop it and then just create a new study so that it doesn't lock up my computer. Go to mesh view again, and then maybe we can just adjust it right here and not go crazy with adding a lot of extra stuff. So we want the average element size to be uniform across the whole thing, I'm guessing. And then mesh view, wait, I'm sorry. We want to leave the mesh view on. We just want to update it. There it is. And so now you can see the sizes of these are comparable to those. So we like that kind of appearance. And oh, did we forget? Yeah, I forgot to do the fixed ends because I started a new study. So that means I have to begin that right there, apply. I have to put all the elements back in, including the force. And it's going the wrong way. Let's see if we can get in here and edit that and change the direction. That was a compression. And then run our simulation. See if it's going to take too long. Not too bad. Uh, what happened to our mesh? Local mesh control. Um, Mesh view. Okay. So now we can see those elements on there. So the maximum that I got in megapascals is 374. Dare I go more or higher with that? I'll just go to 25 like that, apply, And let's just see how much this is going to add to our simulation. Okay. And you can see that most of the stress happens here, which is really why we put a fillet in that area. So without that fillet, there's going to be even more stress in this area. Remember, you can also go over here to displacement and activate that. And not too surprising that relative to the fixed wall, this end stretches the most, obviously. This gives you the overall stretch also of basically zero point 0.1 millimeters for the mesh analysis I have here. All right, let's save that. Make sure you do your screenshots for the D2L assignment. Let's do this last one. Looks like we have a T and an L. So we will just freeform that in. And I use my old method where I do a screenshot and I pull that into Autodesk Inventor. So I'll call this 17.2. And I guess I can close this out, begin a new. We're still in metric or not. Because of PSI, we're going to have to assume that these are in inches, but it also says it right there. We're alloy steel, so let's not forget that. And now we're going to put a pressure down here rather than a force. So with all that being said, let's get started. And one of the things I like to do is, look at one of these dimensions and draw it first with the correct size. So that way, when it rescales, or yeah, it doesn't cross lines from the freeform sketch. So you'll see what I mean. I'm going to go over like this, and before I hit enter, I'm going to type in 10 for the 10 inches. Now it says millimeters there, so I must have clicked the wrong thing. You probably caught that in the video, so we're not going to save this one. File new, English, here, create, put this against the back wall. Now you see it says inches. And so from there, I think we just need to go up like this, over, and you see I did a bad job on that one. And so I could get everything roughed out. That was probably a little too rough. So pull in our image optionally. You see, that wasn't it. Desktop. Uh, there it is. And maybe I can stretch it out a little bit. Maybe I can move it down. Surprise. All right. And so you can see that I've done some not careful work here by, um, we want to make sure that's vertical. This is vertical. That's vertical. It already is. I just wasn't careful enough when I was drawing those, but that's okay. That's what this tool is for. It reminds us when we already have it. See what I mean about that? I don't know what that was about. I'll try that one more time. It should say y-axis vertical. Okay, I'm not sure what it was doing there. I bet this is going to be centered on this area here. So let's make this, first of all, 5 inches. And this one right here, 1 inch. Now let's keep a tally down on the lower right-hand side about how many dimensions are remaining to finish this up. Don't you just love design? It's almost like solving a puzzle. Can you get everything constrained? I think I'm going to put these quarter inch fillets in as a sketch. So 0.25 here for the fillet, or the round, as they say. That's going to add some strength in that area, less likely to fracture at that point. We don't have a fillet down here on the lower right-hand side. Let's see what else we need to do. Okay, you can see that the height of this needs to be exactly 2. And let's see, the height of this one needs to be 0.5. And then from here all the way down to the bottom needs to be 10.5. Okay. We just need to make that symmetric, which we will do in just a moment. Let's see. Well, I guess they made it kind of easy for us by putting this 2 in there. So I was going to do some fancy symmetric work, but looks like they're just making it really easy for us here. Are we fully constrained? Of course not, because we have the sketch in place. But if we delete the sketch, go to the front view, we are fully constrained. But then I forgot how thick this thing needs to be. And it needs to be, let's see, looking for the thickness, 2.5. And we're going to put 100 pounds per square inch down here on this plate. Probably going to glue this to the ceiling. See if I can remember all this stuff. So as a precaution, we're going to do a bi-directional extrude, just in case. That helps us with symmetry. And we want to make sure we read the question carefully, that it doesn't really say where it's that the top is glued to the, or adhered to any surface, but we're going to have to assume that, I believe. And let's not forget alloy steel as well. So right click on this one, Eye Properties, Physical Properties, Material, and then Steel, Alloy. Apply, close, and let's save this part for our simulation. This is going to be 17.2. Looks good. And you know what to do next, right? We need to go into Environments, Stress Analysis, start our case study, or create a study. It's going to be a static analysis. We're not going to let it move. And we'll glue this top part right here to some horizontal plane above us. Now, I don't see it still there. So maybe I forgot to hit apply, because we really need to make sure that symbol is there. So that's a good point. Now we see we're using pressure instead of force. This is going to be, in pounds or newtons, but this will be in PSI, or newtons per square meter. But in this case, we are going to do 100 of those, and we're going to put it right here. I don't know what automatic face chain means, so we're not going to worry about that one. And I think in the book here, they have it symbolically drawn like this, but in the actual application, they say this pressure is across the whole plate, but just represented by 4 arrows. That's kind of unfortunate, but that's the way it is. Is it time for our analysis? Let's look and see what the mesh looks like, and go ahead and preemptively make the average size of the mesh the same across everything. And so if we right click and say update mesh, gives us a nice uniform little fracture points, little elements simulation. And we're going to do a stress analysis. You can see it's right there at the bend point. That's where it's most likely going to fracture. Uh, and if you put a bigger fillet in there, there's probably going to be less stress at that position. Okay, and then the other thing we want to do is see if we can look at the deflection rather, and you can see where it was right here, and then where it bent to. If you look at the front, you can see an exaggerated view of the bending process. All right, let's see if that's all I needed to do here. Yeah, make sure we do 2 screenshots for each of these, upload those into D2L, and you have completed our next part here on stress analysis, right? It was found under environments under this button right here. Good tool for helping us determine where to put more structural support. All right, let's save, finish the analysis, and close out. I'll see you in the next video.